Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
Hello friends, a very good evening to all of you. So guys, today is the last day of 2020. Definitely for a lot of households, this was quite a difficult year. We people who are working online, they did not have to face so many hardships. In fact, for us, hardships were very less. But for the people who are engaged in especially the people who are working as operators in various industries, or the people who are involved in construction business or anything you can take, otherwise. So those people had to face a lot of problems, and I hope that for all those people, the next year would be good year, and for you also, for you as students. So you will take a lot of you will set a lot of targets for yourself, because engineering is the best thing that can ever happen to you. Believe me, marriage is not the best thing. No, sorry, my wife is here. Marriage is the best thing. Okay, so marriage is the best thing. After marriage, engineering is the best thing. She is looking at me from the side, so I can't see on that side now. She's very angry. So it's like take a lot of targets for yourself in terms of learning, and believe me, engineering will give you a lot of knowledge, and if you have knowledge, you will earn money also, you will earn respect also. ठीक है? हाँ, Anish, how are you? So ठीक है, so start करते हैं. So today's concept through question, that is buoyancy. So buoyancy is quite a simple topic in GATE exam also, IES exam also, and I know it's new year, so I will not take much time of yours. But one thing I can remember, I think last time I told I promised that I will make some application oriented question for you, and I think I said that we are going to discuss about, we will not discuss too much about it, but we will solve a question on it. So what we will do, we will solve a basic question on Falkirk wheel, and once that basic question is done, we will see some possible type of questions in buoyancy that are asked again and again. buoyancy में मैं कोई बहुत specific question नहीं कराने वाला हूँ, कोई बहुत डिफरेंट टाइप का क्वेश्चन नहीं कराने वाला हूँ, क्योंकि जनरली एक तो इसकी फ्रीक्वेंसी बहुत कम रहती है, और जो क्वेश्चन आते भी हैं वो बहुत सिंपल आते हैं. सो अभी आपने पास्ट 3-4 इयर्स में देखे ही हैं एक दो क्वेश्चन, तो काफी सिंपल क्वेश्चन रहे हैं, एंड थ्रू आउट द 30 years ऑफ GATE exam, questions have been quite simple. Okay, so guys, who is going to tell me what is this? Any idea? Have you seen it? Civil engineers, if any civil student is going to watch the video later on, I think he or she might know about it. What about mechanical engineers? तो जो लोग भी वीडियो देख रहे हैं, कौन बताएगा ये क्या है? अनीश, ये मैंने पता है क्या किया, गूगल पे गया, गूगल पे सर्च किया और पहला इमेज निकाल लिया. So anyone not seen? Anyone else? So I think there are 4 people. Out of those 4 people watching, I'm myself one. So there are 3 students and Anish is there. So 4 students are there. So anyone, what is this? Any idea? What is this? No? So it's very easy. Actually, the name of this construction, this is not a construction. Actually, it's a moving part. It's a mechanism. So this entire thing, this is called as Falkirk wheel. What? Falkirk wheel. And this guy, he lives in Scotland. Falkirk wheel. तो स्कॉटलैंड में क्या है? हाय दीपांकर, क्या हाल है, कैसा है तेरा लास्ट डे ऑफ दिस ईयर? So I won't take much time, maximum 40-45 minutes. फटाफट इस पे एक बेसिक क्वेश्चन सॉल्व करेंगे, 4-5 क्वेश्चन देखेंगे buoyancy के और रैप अप कर देंगे. ठीक है, तो ज्यादा टाइम वेस्ट नहीं करेंगे. So this is Falkirk wheel and this is located in Scotland. So I hope you can see that there is a bridge over here, है ना? Actually this bridge goes into a canal, and I don't remember now correctly. I have read it quite 2-3 years back, तो मुझे exactly याद नहीं है. शायद इस कैनाल का नाम यूनियन कैनाल है, और ये वाले कैनाल का नाम मेरे ख्याल से 4th and Clyde कैनाल है. Okay, so one of them is Union Canal and one of them is 4th and Clyde canal. So these are 2 separate canals, and actually these canals, they have an elevation difference between them. So earlier what would happen, that if there was a boat, so like here you can see now a lot of boats are there. There are so many boats are there. Okay, so this is not a boat. I'm sorry. But this one is a boat, right? This one is a boat. So suppose a boat wants to go from 4th and Clyde Canal to the Union Canal. So earlier there was a lock system. Does anyone know what a lock system is? Any idea? Please be quick. Please do let me know. दीपांकर बेटा एक बार चेक करना कि क्या मेरी वीडियो हैंग हो रही है. आई होप माई वीडियो इज नॉट गेटिंग हैंग्ड. आई होप माई वीडियो इज नॉट गेटिंग हैंग्ड. यहां से तो सही चल रहा है काम बिल्कुल. एनीवन? हाँ. सो डज एनीवन लॉक करके वाटर लेवल इंक्रीज करते होंगे? हाँ बिल्कुल सही है, ऐसा ही करते हैं, ऐसा ही करते हैं. सो अर्लियर देयर वाज अ लॉक सिस्टम. So in case of lock system, what you have is you have multiple chambers, open chambers. So ship from one canal will go into a chamber. The level of water in the chamber will be increased. Ship will rise a little. Then it will go into another chamber. In that chamber, then we will increase the water level and ultimately it will go to the canal at higher elevation. So like this. तो आई होप समझ पा रहे हैं. ठीक है. तो क्या होता है, क्लोज्ड चैम्बर्स होते हैं, लीक प्रूफ चैम्बर्स होते हैं. तो मान लीजिए आप क्या करते हैं, पहले शिप को एक चैम्बर में ले आते हैं, उसके डोर्स को क्लोज्ड कर देते हैं. डोर्स आर लीक प्रूफ. देन यू इंक्रीज द लेवल ऑफ वाटर इन द चैम्बर, सो शिप विल राइज अप. नाउ यू ओपन द अदर गेट, सो शिप विल गो इनटू द सेकंड कैनाल. सो दिस वाज कॉल्ड एज लॉक्ड सिस्टम. नाउ हाँ, तो सूज कैनाल, पनामा कैनाल, इस तरह के जो कैनाल्स हैं वहां पे पहले इसी तरह के सिस्टम्स होते थे. And then lift system came into picture. So in USA and Britain, there are a lot of lift systems. So right now we are not going to talk about that. Now that canal system, first of all, it required very heavy pumps. So those pumps will consume a lot of power and the whole process will take around 1 day. So for a ship to go from one canal to the other canal through that lock system, the whole process took 1 day. So this was an inefficient process. And because of the inefficiency, the system was closed down in 1930s. Then in 1999, someone came out with this idea and they replaced the lock system with this, which is called as Falkirk wheel. So actually, I hope you can see that, just a second guys, I hope you can see that there is something in the middle. Actually this is a shaft. This is a shaft, okay? And on this shaft we have these arms. We have these arms. So these arms are like always parallel, okay? So if the shaft rotates, these arms will rotate along with it. And on one side of the shaft, I hope you can see that there is a tub. This is called as, I'm not sure now, but I think they call it as caissoni, something like this. You can call it as a tub. So here you have a tub and here also you have a tub. So suppose there is a ship in the bottom canal. So what they will do, they will open the gate of the tub and the ship in the bottom canal will go into the tub. They will rotate it. The tub will go up and then again they will open the gate and the ship in the tub will go into the Union Canal. Similarly, if there is a ship in Union Canal, they will open the gate of upper tub, the ship will come inside, they will close the gate and then they will rotate the Falkirk wheel. The tub will come down and ship will go outside. So like this, a basic procedure is there, okay? So guys, you understood now basic idea? I hope you guys understood the basic idea, or do you want me to show you another picture of this? Do you want me to show you another picture of this? Guys, please do let me know. I think I have found something. और इसका image quality भी ठीक लग रहा है. Image quality भी ठीक लग रहा है इसका. तो इसको copy paste कर देते हैं. Copy paste कर देते हैं. Like this. Right? ठीक है. Good. Good. So I hope now you can see. This is one tub. This is one tub over here. So in the tub there is a ship. There is another tub. In this tub also there is a ship. Actually they are not ships. They are boats. They are ferries. Like 20 ton, 30 ton at max. Okay. Something like this. अब जरा देखो, अब मैं आपको एक क्वेश्चन पूछता हूं, ठीक है? लेट मी आस्क यू अ क्वेश्चन. नाउ द क्वेश्चन इज कि लेट अस सपोज, एक बार ड्रॉ करके देख लेता हूं सही बनता है या नहीं. सो लेट अस सपोज this is the canal at the upper elevation. This is the canal at the upper elevation. And obviously, in this canal, there will be some water. In the water, there is a ship which is floating, and in front of the ship, there is the tub. So let me draw the tub in a separate color. So this is the tub. This is the tub. Obviously, if the gate of the tub is open, then the level of water in the tub and the canal will be same, right? Now I don't remember the actual values, but I am considering that this tub, it has a total weight of 500 ton. Maybe it is higher value. The value I have taken, it might be higher also, but I am just taking some example values. And the water inside the tub right now, it is 500 tons. Okay, this is 500 tons. And maybe this ferry has a total weight of 20 tons, just for example's sake. Okay, now this tub is actually connected with the tub at the bottom. So in this tub also there will be water. And just for sake of simplicity, let me consider in this tub also the water level is 500 ton, and there is a canal in front of it. There is a canal in front of it. When the gates are open for the tub, the level of water in the tub and level of water in the canal will be same. Okay, and this is the middle shaft. This is the middle shaft around which this arm of the Falkirk wheel, this entire arm of the Falkirk wheel, this entire arm is going to rotate. And obviously this is some kind of pivot to hold the shaft. ठीक है, इस तरह से एक बेस बना दिया, ठीक है ना, ऐसे करके. simple idea. Okay, now what will happen, we want to take down the ship to the bottom, the ferry to the bottom. So what we will do, we will open the gate of the upper tub. The ferry will come inside. We will close the gate, and then we will rotate this shaft with help of some hydraulic motors. So in actual there are, I think, 8 or 10 hydraulic motors. Now my very first question is that let us suppose we are rotating the arm, and at a particular time instant the arm is at some angle with the horizontal as well as the vertical. The arm is not entirely vertical, the arm is not entirely horizontal, but arm is at some angle with both the directions. Okay, let us take this as an example. So this is the arm, and with each arm there is a tub attached with it. Okay, this is the upper arm, and the upper tub. ओके, इसका एक वर्ड होता है कैसोनी करके, मैं उसका नाम भूल गया हूं, उस वर्ड को कहते क्या है. Now in this tub there is a ship also, and the weight of the ship is 20 tons. How much is the weight of the ship? 20 tons. I think Falkirk arm, that is the distance between the tubs, I think that is 24 meters. So you can consider this to be 10 meter, this to be 10 meter, and this also to be 10 meter. You can consider that the weight of each of the tub is 500 tons, and when there was no ship in the tub, the water in the tub was also 500 tons. ये मेरा पहला क्वेश्चन है. Right now, how much torque is required to maintain this system at this particular position, 45-degree angle, say for example. आई होप आप लोगों को समझ आया मेरा पहला क्वेश्चन क्या है. मेरा पहला क्वेश्चन ये है कि हमने क्या किया, हमने यहाँ पे शिप आगे अंदर और यहाँ तो कोई शिप नहीं है, बट वी हैव रोटेटेड द आर्म एंड वी हैव स्टॉप द आर्म एट एन एंगल ऑफ 45 डिग्री एंगल. So my first question is, in order to keep this arm at equilibrium, how much external torque is required? दीपांकर, अनीश, जो लोग भी वीडियो देख रहे हैं, I hope you got the point. Anyone who is watching the video, I hope you got the point. I want to hold the arm not horizontal, not vertical. I want to hold the arm like this at an angle of 45 degree. So this is the tub where I have a ship of 20 tons and this is the tub in which there is only water. Initial weight of water, initial weight of water in the tubs is given, weight of each tub is given, and the weight of ship is also given. मुझे क्या पता, ये तो आपको फाइंड आउट करना है ना, यही तो दीपांकर फाइंड आउट करना है बेटा, यही तो फाइंड आउट करना है कि अब कितना पानी होगा टब के अंदर. हाँ, सो फाइंड आउट करो. वेरी गुड, टोटली सही है, टोटली सही है. हमें यही फाइंड आउट करना है कि एक बार शिप टब के अंदर आ जाता है तो टब के अंदर पानी कितना होगा. पानी का वेट पता लग गया, शिप का वेट पता लग गया, सारी वेट पता है. वेट इनटू डिस्टेंस टॉर्क होता है, तो टॉर्क फाइंड आउट करो. ऑल ऑफ यू प्लीज चेक. अनीश बेटा प्लीज डू रिप्लाई. अनीश बेटा प्लीज डू रिप्लाई. दोज पीपल हु हैव जॉइंड जस्ट नाउ, for them we are solving this structure. This structure is called as Falkirk wheel, and actually these people are going to make out an amazing point about this structure. A very amazing point about this structure. Hello Arbaz, how are you? So Arbaz, beta, I'm not sure whether you have joined just now or a little earlier. So I am discussing Falkirk wheel and I have given them a question. So please do let me know if you do not know the question. I will explain it to you. ठीक है? अनीश, दीपांकर, बेटा सोचो क्या आंसर आएगा. How much is the answer? How much is the answer? Take your time. Don't worry at all. Till then I will draw some figure. मैं अभी एक आध फिगर बना लेता हूं तब तक मैं भी एक आध फिगर बना लेता हूं. अच्छा, दीपांकर कह रहा है 0 होगा, बट 0 क्यों होगा बेटा, है उसमें 20 टन का शिप नहीं आ गया अंदर, है बेटा, 20 टन का शिप आ गया ना बेटा, तो मेरे ख्याल से तो मोमेंट आएगा, नेट मोमेंट आएगा. 20 टन का शिप आ गया अंदर, नेट मोमेंट नहीं आएगा. 20 टन का शिप अंदर आ गया. अच्छा, तो वो कितना पानी बाहर जाएगा. नहीं, अरबाज बिल्कुल भी मैथ पे बेस्ड नहीं है, बिल्कुल भी मैथ पे बेस्ड नहीं है बेटा, सिर्फ ब्योएंसी प्रिंसिपल पे बेस्ड है एक्चुअली. पर वो कितना पानी बाहर जाएगा, ये भी तो क्वेश्चन है ना. क्वेश्चन ये है कितना पानी बाहर जाएगा. क्वेश्चन ये है कितना पानी बाहर जाएगा. कितना पानी बाहर जाएगा. अच्छा ठीक है, तो एक काम करते हैं, ये क्वेश्चन मैं क्विकली सॉल्व करता हूं और फिर नेक्स्ट क्वेश्चन देता हूं. ठीक है, बहुत सही आंसर है दीपांकर का. इट इज 0. Actually, the answer is 0, and this is the advantage of this structure. Whether there is a ship in the tub or not, whether in one tub there is a 30-ton ship and in the other ton there is a 20-ton ship. आप समझ रहे हैं, यहाँ पे 20-ton ship है और यहाँ पे 30-ton ship है. चाहे ऐसा भी हो तो भी फर्क नहीं पड़ता. The weight of this entire tub and the weight of this entire tub, they are always equal and they balance each other. ये हमेशा इक्वल होते हैं और ये हमेशा बैलेंस करते हैं एक दूसरे को. और इसी कारण से यही एक रीजन है that when you are rotating this Falkirk wheel, the Falkirk wheel will consume very less amount of power, and in one round it consumes a power which is equal to boiling of 8 kettles of water. सिर्फ इतना पावर चाहिए होता है उसको, सिर्फ इतना पावर चाहिए होता है और आप 20 टन शिप को ऊपर से नीचे ला सकते हैं या नीचे से ऊपर भी ला सकते हैं। सिर्फ इतना ही पावर चाहिए कि हम 8 केटल्स में, यानी कि कह लो 16 लीटर कह लो, 15 लीटर पानी को बॉयल करते हैं ना, उतना ही पावर चाहिए। आओ देखते हैं कैसे। लेट अस सी हाउ। So for this, first of all, let us quickly revise what is your buoyancy principle. So buoyancy principle says that, sir, let us suppose this is the cross section of the ship. Let us suppose this is the cross section of the ship. And right now the ship is in floating condition. The ship is in equilibrium. So based on the concept of pressure, you will say this surface is exposed to water. So on this surface, there will be a pressure distribution. So because of the pressure distribution, there will be a pressure force. Similarly, on the other surface also, there will be a pressure distribution. So because of this pressure distribution also, there will be a pressure force Fp2. So like this, on all the surfaces of the ship, there will be a pressure force vector. Now, when we are going to add all the pressure forces vector, we will get the resultant pressure force vector. So resultant pressure force vector is Fp1 plus Fp2 plus Fp3 and so on. Basically the sum of pressure forces on all the surfaces. Now these surfaces can be planar surfaces, inclined or vertical surfaces. These surfaces can be curved surfaces also. So sum of the pressure forces for all surfaces is equal to the resultant pressure force on the body, that is the buoyant force. इसी force को आप क्या कहते हैं? Buoyant force कहते हैं. And this buoyant force is nothing but it is equal to weight of fluid displaced. Buoyant force किसके बराबर होती है? Weight of fluid displaced के बराबर होती है. So what you will say? You will say, sir, this is the ship. This is the ship. And the level of water is this much. So how much water is removed by the ship? The water removed by the ship is this much, है ना? So weight of this volume, which will be called as displaced volume of water. So you will say the weight of displaced volume of water, that is density of water into volume of displaced water into acceleration due to gravity. This weight is actually equal to the magnitude of buoyant force, that is the resultant pressure force on the body. And this buoyant force always acts in the upward direction. Now please note that this volume of water displaced will have a center of gravity. This center of gravity of the volume of water displaced, this is called as center of buoyancy of the body, that is the ship. So buoyant force always passes through center of buoyancy of the ship, that is volume of water displaced. ठीक है ना? But this entire ship will have its own center of gravity also, and this is where the weight of ship is going to act. But if the body is in equilibrium, the buoyant force is equal to weight of the ship. Am I correct? Am I correct? हाँ दीपांकर बेटा बिल्कुल सही है, बिल्कुल सही है. बस अब क्विकली से इसको सॉल्व कर देते हैं. So Anish, Dipankar, Arbaz, all of you who are watching the video, please be quick. Am I correct or not? Am I correct or not? Am I correct? This means if we are talking of floating body, the weight of body is equal to weight of fluid displaced. If we are talking of a floating body, the weight of body is equal to weight of fluid displaced. है ना? Now check for yourself. Check for yourself. So what was the weight of the ship? So 20 ton. That is mass actually. 20,000 kg. है ना? So what is the weight of the boat? It is 20 tons. So how much water is displaced by the boat? 20 tons. So weight of water displaced by the boat is 20 tons. Now what you will do? First of all, you will remove this gate, this particular gate. And what will happen? The ship will come inside. But when the ship will come inside, the 20 tons of water will go outside. The ship is always floating, so it is always going to displace 20 tons of water. So when this ship will come inside, 20 tons of water will go outside. Yes or no? Am I correct? Am I correct? All of you, please do let me know. Now, how much was the initial weight of water in the tub? 500 ton. How much water went outside? 20 ton. So this is the new weight of water in the tub. But apart from water in the tub, there is ship also. So what is the total weight of things in the tub? That is 500 ton. So actually, this total weight of the tub always remains conserved. Am I correct? The total weight of the tub always remains conserved. So what will happen? What will happen? This total is 1000 Newton. This total is 1000 ton. They will always balance each other. And this is the beauty of Falkirk wheel. Whether one tub has a bigger ship and the other tub has a smaller ship. Whether in one tub there are two ships and in the other tub there is no ship. In any of the case, the two tubs have same weight. So the torque created by their weights balance out each other, and Falkirk wheel is in equilibrium by itself. It is always in equilibrium by itself. समझ रहे हैं आप मेरी बात? All of you, please do let me know. All of you, please do let me know. Now you will ask me, sir, what is the advantage of this? Beta, the advantage of this is, let us suppose there is only one tub. Let us suppose there is only one tub. Only one tub is there. And I want to take the ship from the bottom canal to the upper canal. Now check what will happen. To take the ship from the bottom canal to the upper canal, you have to apply a lot of torque. You have to apply a lot of power. If you want to bring the ship down, then it is very easy because it will come down by its weight only. है ना? Now it will come down by its weight only. But in order to take this up, you have to apply additional torque. Too much power will be consumed. But you know what? It is always in equilibrium. So only torque you need to apply is to balance the friction force. Yes or no? Please be fast. Please do let me know. बट सर द लेवल ऑफ बोथ, हाँ सो दीपांकर बेटा एक्चुअल में ऐसा नहीं होता है. एक्चुअल में क्या होता है, जो लेवल ऑफ वाटर है ना वो चेंज करता रहता है सीजनल फ्लक्चुएशन के अकॉर्डिंगली. तो उसके लिए भी उन्होंने मैकेनिज्म्स बनाए हुए हैं. तो ऐसा नहीं है कि मतलब सेम वो चीज है, सिर्फ सेम लेवल पे ही काम करता है. उसके लिए भी एडिशनल मैकेनिज्म्स है, मगर वो थोड़ा कॉम्प्लिकेटेड है. तो मैंने सोचा यार फिर थ्योरी ऑफ मशीन्स आ जाएगा तो उसकी बात नहीं करते हैं. इनफैक्ट एक मजेदार चीज दिखाऊं, ये देख रहे हो यहाँ गियर भी लगा हुआ है, यहाँ गियर भी है. देख रहे हो यहाँ पे गियर लगा हुआ है. यहाँ एक बड़ा सा गियर दिख रहा होगा. एक्चुअल में यहाँ बीच में एक और गियर भी है और यहाँ भी एक गियर है. उसका भी एक मीनिंग है. और यहाँ पे डॉक्स भी होते हैं. सो मैंने पहले पढ़ा था कुछ साल पहले ना, इसकी एंटायर कंस्ट्रक्शन पता है मेरे को, इसका डिजाइन मेरे को पता है, पर फिर वो थोड़ा सा लंबा लेंदी हो जाएगा तो अभी के लिए उसको अवॉइड कर देते हैं. ठीक है, अभी यहीं चलते हैं. हाँ कहाँ पहुंच गए थे हम लोग? हाँ यहाँ पे थे. ठीक है, सो वन क्वेश्चन इज सॉल्व. वन क्वेश्चन इज सॉल्व गाइस, वन क्वेश्चन इज सॉल्व. All of you please do let me know. हाँ स्पर गियर है, स्पर गियर है, मगर वहां पे ना एक गियर ट्रेन है, एक छोटा सा गियर ट्रेन है. All of you please do let me know if this is clear or not. First question is clear. First question is clear. A floating body will always displace water equal to its own weight. So when 20-ton ship is floating, it is displacing 20-ton amount of water. Now the gate of the tub is open, so water can come inside also and water can go outside also. So when the ship will come inside, water will go outside. And how much water will go outside? 20-ton water will go outside. So total weight of the ship will remain conserved. Okay? Now let me give you a question. One more question. Okay? So I had given you the weight of each tub is equal to 500 ton. By the way, I think this value is too large. I'm not sure how much it is. Maybe it is 200 ton or something. So 500 ton means maybe along with water. So ton कितना होता है? 1000 kg होता है. So weight of each tub is 500 ton. Initial weight of water in each tub is 500 ton. Okay. And my question is, if in the upper tub, the ship that will come inside is 20 tons. How much tons? 20 tons. Okay, in the lower tub, the ship that will come inside is 10 tons, and the frictional torque in the bearings of the shaft. So shaft is going to rotate in some bearings, and there will be a motor which is going to rotate the shaft. So that motor is balancing the frictional torque, है ना? Motor has to balance only the frictional torque because these two things are always balanced. So only thing you need to overcome is this friction. Once you overcome the friction over here, you can rotate the arm. So that frictional torque is maybe given to us as 1.15 Newton, mega Newton meter. Mega Newton meter. Okay. Okay. Now my question is to bring this upper ship down and this lower ship up, how much power consumption will happen? मेरा क्या क्वेश्चन है कि पावर कंजम्पशन कितना होगा, ये मेरा क्वेश्चन है. दिस इज माई क्वेश्चन. This is my question. To take the upper ship down and lower ship up, how much will be the power consumption? How much will be the power consumption? So I think some students have joined new. So all those students have joined new. They can, I'll just give you a hint. So guys, we are talking of Falkirk wheel. तो आप क्या कर सकते हो, आप वीडियो को थोड़ा सा पीछे ले जा सकते हो और चेक कर सकते हो कि मैंने क्वेश्चन क्या दिया है. तो मैंने क्वेश्चन दिया था कि अगर एक टब में 20 टन का शिप है और दूसरे टब में कोई शिप नहीं है, तो जब हमारे लीवर की पोजीशन 45 डिग्री होगी हॉरिजॉन्टल में के साथ, तो लीवर को इक्विलिब्रियम में रखने के लिए कितना टॉर्क लगाना पड़ेगा, ये मेरा क्वेश्चन था. ओके और मैंने नेक्स्ट जो क्वेश्चन दिया है, मेरा नेक्स्ट क्वेश्चन ये है कि ऊपर वाला जो टब है कसौनी जो भी है, उसमें 20 टन का शिप आया है और नीचे वाला जो टब है उसमें 10 टन की बोट आई है. बोट्स बेसिकली, दीज आर बोट्स, दीज आर क्वाइट लाइट बोट्स. तो लोअर टब को ऊपर लेके जाना है और अपर टब को नीचे लेके आना है. जो फ्रिक्शनल टॉर्क है दैट इज 1.15 मेगा न्यूटन मीटर. ऑब्वियसली यू कैन निग्लेक्ट एनी काइंड ऑफ रोटेशनल स्पीड, देयर इज नो काइनेटिक एनर्जी इन द सिस्टम. हाँ, एनर्जी कंजम्पशन. ओके सो गाइज आई कैन सी देयर इज अ डिसलाइक. सो गाइज डेफिनेटली दैट इज योर राइट, है ना. अगर आपको पसंद नहीं आया तो आप डेफिनेटली डिसलाइक कर सकते हो, बट मुझे भी बता दिया करो ताकि मैं भी अपने आप को इम्प्रूव कर सकूं. जहां भी प्रॉब्लम लगे आप मेरे को ना एक बार बताओ जरूर कि सर ये चीजें जो है इम्प्रूव करनी है. ठीक है. ओके सो गाइज प्लीज डू लेट मी नो. चेक करो, सोचो थोड़ा सा कि क्या कर सकते हैं. तब तक मैं भी एक बार क्विकली रिवाइज कर सकता हूं कि ब्योएंसी में किस किस तरह के क्वेश्चंस आते हैं. ये तो वैसे अब ब्योएंसी से रिलेटेड नहीं है, दिस इज एनर्जी कंजर्वेशन प्रिंसिपल ओनली. ओके सो दिस इज मोर लाइक अ क्वेश्चन ऑफ मैकेनिक्स, बट लेट मी ऑल्सो गो थ्रू कि एक बार फटाफट से ब्योएंसी के जो बेसिक क्वेश्चंस आते हैं एक बार उनको क्विकली गो थ्रू कर लेते हैं. सॉल्व नहीं करेंगे, गो थ्रू कर लेंगे. सॉल्व नहीं करेंगे, गो थ्रू कर लेंगे. So please do try and let me know if this is clear or not. दीपांकर बेटा 11.5 मेगा न्यूटन, थोड़ा सा कुछ गड़बड़ हो गया. मेगा न्यूटन नहीं आएगा बेटा, जूल्स में आएगा. किस में आएगा? जूल्स में आएगा. मेगा न्यूटन में नहीं आएगा, जूल्स में आएगा. और हम पता है क्या करेंगे, हम उसको किलोवाट आवर में कन्वर्ट करके, इंडिया में एक यूनिट 8 रुपए का होता है ना कई जगह पे, तो उसको 8 रुपए से मल्टीप्लाई करके कॉस्ट निकाल देंगे कि कितना कॉस्ट लगेगा एक चक्कर के लिए. और वैसे वहां रियल में क्या होता है, so रियल में दिस लीवर इज ऑलवेज इन इक्विलिब्रियम, सो आइदर यू रोटेट इट एंटी क्लॉकवाइज और यू रोटेट इट क्लॉकवाइज. तो वहां जो ऑपरेटर होता है ना, वो पता है क्या करता है, एक बार क्लॉकवाइज घुमाता है, एक बार एंटी क्लॉकवाइज घुमाता है. उससे क्या है कि बेरिंग का जो वेयरिंग होता है ना, वो यूनिफॉर्म वे में होता है. सो ये हाँ एक ही राउंड है. गियर का बेटा मतलब क्या है कि जो मिडल गियर होता है उसका तो हाफ राउंड आएगा ना बेटा, 180 डिग्री. मिडल गियर का तो 180 डिग्री आएगा. मगर वो जो छोटा गियर है उसका रोटेशन थोड़ा डिफरेंट आएगा ना, ω1 R1 इज इक्वल टू ω2 R2। अच्छा सॉरी, मैंने आपको छोटे गियर्स के बारे में नहीं बताया ना। सो यहाँ पे और भी गियर्स हैं, यहाँ पे और भी गियर्स हैं, ठीक है। सो एक्चुअल में क्या होता है, ये यहाँ पे एक गियर होता है, ये यहाँ पे एक गियर होता है और यहाँ पे गियर होता है। ये वाला गियर और ये वाला गियर सेम साइज का है, तो इनकी रोटेशन बराबर होती है, दोनों की 180 डिग्री 180 डिग्री। यहाँ पे गियर क्यों लगाते हैं, यहाँ पे गियर इसलिए लगाते हैं ताकि जब गोंडोला नीचे जाएगा या ऊपर आएगा ना, तो गोंडोला में जो पानी है उसका इनर्शिया भी होगा, उस इनर्शिया के कारण झटके लगते हैं, उनको अवॉइड करने के लिए ऐसा किया जाता है। तो वो गोंडोला हमेशा स्टेबल रहती है। सो ये रोटेट करता है 180 डिग्री, ये रोटेट करता है 180 डिग्री। अब इसका मुझे साइज नहीं पता, तो वो साइज पता होंगे तभी आप बता सकते हैं। मैंने एक बार पढ़ा था, इसकी कंप्लीट स्ट्रक्चर पढ़ी थी, अभी थोड़ा सा धुंधला धुंधला सा याद है, तो मैं कोशिश करूंगा किसी दिन टाइम होगा गेट एग्जाम के बाद तो सिखाऊंगा। इसके पीछे थ्योरी ऑफ मशीन भी है, थोड़ा सा थ्योरी ऑफ मशीन भी है, इसमें सॉम भी लगेगा, बहुत बढ़िया स्ट्रक्चर है ये। एनी आंसर्स प्लीज? अरे बड़ा आसान है बेटे, बहुत आसान है, ये देखो मैं बताता हूं। सो व्हेन यू आर अप्लाइंग टॉर्क on the entire system, what is the purpose of the system? So when you apply torque on some system and the system is rotating, basically you are transmitting power to the system. So power transmitted to a system is equal to change in energy of the system plus frictional losses. ऐसा ही है ना? The power supplied to the system, power supplied to the system. So basically we will say like this: total energy supplied to the system, total energy supplied to the system। अच्छा मैं समझ गया, आप पावर की बात कर रहे हैं, क्योंकि मेरे ख्याल से पावर के लिए टाइम पीरियड निकालना होगा, है ना। सो टाइम पीरियड 4 मिनट्स का होता है, वहां पे टाइम पीरियड 4 मिनट्स का होता है, सॉरी मैं टाइम पीरियड देना भूल गया। सो वन राउंड मीन्स फ्रॉम अप टू बॉटम एंड बॉटम टू टॉप। सो वन टब विल गो टॉप एंड द अदर टब विल गो बॉटम, so that round is 4 minutes. I'm sorry, ठीक है, 4 minutes. Now check. So energy supplied is equal to change in energy of the system. Now what do you mean by change in energy of the system? One object comes down, so there is a change in potential energy. Other object goes up, so there is a change in potential energy. So what you will say? You will say change in potential energy of object 1 is equal to change in potential energy of object 2 plus there will be losses against friction. Yes or no? Am I correct? Am I correct? All of you, please do let me know. Please do let me know. Now what is the object? So every object is 100 tons, 1000 tons. So 1000 ton object comes down, है ना। इसके अंदर पानी कितना था? इसके अंदर पानी भी 500 टन था, पानी भी कितना था? 500 टन था। So whether the ship is inside or the ship is outside, that doesn't matter. The weight of the tub will remain conserved. And what will be the total weight of the tub? That will be 1000 tons. So this 1000 ton will remain conserved, right? Now if 1000 ton comes down by 24 meter, by how much meter? 24 meter. So diameter of the arm is 24 meter, which is not given in the question because it is not required. So 1000 ton will go down, its potential energy will decrease, negative change of potential energy. 1000 ton will go up, potential energy will increase, positive change of potential energy. So I think this will be a positive term, this will be a negative term, and this entire will become 0. Please do let me know guys, सही बोल रहा हूँ? दीपांकर, अनीश, अरबाज, बेटा जो लोग भी वीडियो देख रहे हो, प्लीज डू लेट मी नो इफ आई एम करेक्ट और नॉट। इफ आई एम करेक्ट और नॉट। 1000 टन नीचे आ गया, कितना नीचे आया भैया? इक्वल टू डायमीटर ऑफ फाल्कर्क व्हील। 1000 टन ऊपर चला गया, कितना? इक्वल टू डायमीटर ऑफ फाल्कर्क व्हील। तो टोटल चेंज इन पोटेंशियल एनर्जी ऑफ द सिस्टम इज हाउ मच? इट इज 0 only. So that only energy which we are supplying is the loss against friction. Now how much is the torque? Frictional torque. So I think I can say the energy lost against friction is equal to torque into angle of rotation. How much is the torque? 1.15 mega Newton meter. And how much is theta? So theta is pi by 2, right? Yes or no? Please do let me know. Please do let me know. So the energy supplied is required to overcome the frictional losses. But this one round takes around 4 minutes. How much? 4 minutes. So what you can do, you can find out the power supplied. So this power supplied will be total energy supplied into divided by total time period, which is 4 minutes. Right? So this will be your answer. This will be your answer in watts, because I have written mega as 10 raised to power 6. So if I do not write this 10 raised to power 6, I will get an answer in megawatts. So let me get the answer. Guys, I think मेरे पास कैलकुलेटर नहीं है, तो मैं ऐसे ही करता हूं फिर. So ये क्या बन जाएगा? है कैलकुलेटर? ओके. So 1.15 into pi divided by 2 divided by 4 divided by 60. So this I am getting as 7.526 into 10 raised to power minus 3 megawatt. So mega means 10 raised to power 6 watts. So this will become 7.526 kilowatt. ये बहुत ज्यादा पावर नहीं है, बहुत कम पावर है. अभी बताता हूं कैसे. हाँ, आगे आंसर. So Dipankar, very good. So Dipankar's answer and my answer is same. So I think we are getting the correct answer. Okay, very good, very nice, good. Now guys, check. What is the marvel over here? Question is, sir, what is the marvel over here? Now just have a look. This amount. Have a look at this amount. Okay. I hope you remember unit. So a unit is 1 kilowatt hour, है ना? So how much is this? 1000 into 3600 joules. This is 1 unit. And in India, especially in metropolitan cities, 1 unit energy is equal to 8 rupees. How much? 8 rupees. Now, how much energy was consumed in the entire process? This was the energy consumed in the entire process. So, Newton meter, that is nothing but joule. है ना? So, Newton meter is nothing but joule. Now, what will you have? You will say 1.15 into 10 raised to power 6 into pi by 2. This is the total energy consumed. How much is a unit? The unit is 1000 into 3600. joules. How much is the cost of 1 unit? 8 rupees. So what will be the total cost? 1.15 into 1000 into shift pi divided by 2 divided by 1000 divided by 3600 into 8. I am getting an answer of 4 rupees. मेरे पास 4 रुपीज आंसर आ रहा है. कितना आंसर आ रहा है? 4 रुपीज आंसर आ रहा है. समझ रहे हैं आप? Isn't this remarkable? Isn't this remarkable? Obviously, मेरा थोड़ा सा जो वैल्यूज है वो इधर उधर है, because the tub weight will be different. Actually, it is not higher. The tub weight is smaller, and the frictional torque can be slightly more, but it is of the same order. So 4 rupees are getting consumed. I think this is a remarkable thing. That's why Falker wheel is so amazing. And it is based only on a simple principle. What is the simple principle? The simple principle is that a floating object displaces water, which is equal to weight of the object. So whether the ship comes inside or goes outside, the weight of the tub remains conserved. So the two tubs on the two ends of the lever, they always balance each other. ठीक है ना? आई होप क्वेश्चन मजेदार था और टाइम की वेस्टेज नहीं हुई. तो मेरे यहाँ पे क्या हो रहा है? मेरे यहाँ पे ना जो YouTube वाला स्क्रीन है वो थोड़ा सा हैंग हो रहा है. सो प्लीज डू लेट मी नो. एक बार मुझे बता दो अगर क्वेश्चन समझ आ गया है, सही लगा है, देन वी विल मूव अ लिटिल अहेड. फिर क्या करते हैं, एक बार क्विकली जो buoyancy से related questions पूछे जा सकते हैं उन questions को cover up कर लेते हैं. So anyone, please do let me know, is there a doubt or not? Please do let me know, is there a doubt or not? Anyone, please do let me know, is there a doubt or not? Any doubts? Any doubts? ठीक है. So I think there is no doubt. So let us quickly go through some basic types of questions. So the very first question that can be, so I always tell you, these questions I will not solve. Okay, these questions I will not solve. One question from ISRO we will solve at the last. तो एक बार फटाफट देख लेते हैं. ठीक है अनीश, very good बेटा. So what we have a tub. In the tub there is some fluid. So density of the fluid will be given to you. Now what they will say? They will say there is an object and the density of the object is given to you. So if you compare the values, the density of object is less than density of fluid. So obviously you will say that this object is displacing some amount of fluid. So how much is the fluid displaced by the object? I think this is the volume of fluid displaced by the object, which is equal to the volume of object only. So because of that, there will be a buoyant force. So on the object, there will be a buoyant force. Now this object is sometimes tied to the bottom with a rope. So you have to find out the tension. So I think you can very easily do it. You will simply say there is a buoyant force in the upward direction. There is a weight of the object in the downward direction. So weight of the object and the tension, they are going to balance the buoyant force. है ना? I think simple concept है. अब इसमें क्या होता है? इसमें tricky चीज क्या होती है? If the density of body is more than density of fluid, the body will sink. Why? Because the buoyant force will be less than weight of the body. Now as soon as the object will go down, the rope will become slack. And if the rope will become slack, the tension in the rope will be zero. है ना? I think this is a simple question. Then one of the question becomes कि भैया this is the level of water, and there is an iceberg. So what is the fraction of iceberg outside water or fraction of iceberg inside water? So again what you say when the object is floating, the weight of the object is equal to buoyant force. How much is the weight of object? Density of body into total volume of body into acceleration due to gravity. How much is the buoyant force? Density of fluid into volume of displaced fluid into acceleration due to gravity. Now what is the volume of displaced fluid? Only this much fluid has been displaced. So this red part becomes the volume of displaced fluid. So if you know the entire volume of body, if you know the density of body, if you know the density of fluid, you can simply say density of body by density of fluid is equal to volume of displaced fluid by volume of body. But what do you mean by displaced fluid? Displaced fluid means how much body is inside water, है ना? Displaced fluid means how much fraction of body is inside water. तो कई बार हम ये क्वेश्चन करते हैं और हमें एक बहुत रिमार्केबल चीज मिलती है. So what we get? We find out that Leonardo DiCaprio, he was able to see only 10% of the iceberg and remaining 90% was actually down. समझ रहे हैं? So what he was looking at was actually a very massive mountain, floating mountain, and only 10% was outside and 90% was inside. Now sometimes we solve a question that bhaiya Ganga river discharges water into the Bay of Bengal. So ocean water has slightly different density than the river water. So river water is more pure. It has less salts. It has less density. So the question becomes, when the ship will go from the river to the ocean water, what will happen to the ship? Whether it will slightly sink or whether it will slightly come out. So again, you can compare the buoyant forces. है ना? So what you will say, whether the ship is floating in fresh water, that is river water, whether the ship is floating in fresh water or the ship is floating in ocean water, in both the cases, the weight of the fluid is equal to weight of buoyant force. Weight of body is equal to weight of buoyant force. So density of fluid, volume of displaced fluid into acceleration due to gravity. Density of fluid, volume of displaced fluid into acceleration due to gravity. So what you can do, you can say the weight of the object will remain the same when the ship goes from fresh water to ocean water, but the density of fluid will change. Accordingly, volume of displaced fluid will change, and you can find out whether the ship will come outside or go inside. ठीक है ना? So बता दो एक बार, क्या मैं सही कह रहा हूँ? एक क्वेश्चन ये भी बनता है ना? All of you, please do let me know. Please do let me know if this is clear or not. Please do let me know if this is clear or not. कर रखे हैं ये सभी ने क्वेश्चंस? देखो ये क्वेश्चन क्यों बता रहा हूँ? ये क्वेश्चन बताने का रीजन ये है कि अगर किसी को भी ऐसा लगता है कि ये पर्टिकुलर क्वेश्चन मैंने नहीं किया है या मुझे नहीं आता है, तो वो अभी नोट डाउन कर सकते हैं, और जैसे ही अभी हम सेशन को ओवर करेंगे 10-15 मिनट में, तो वो लोग मुझसे डाउट पूछ सकते हैं कि सर ये क्वेश्चन कैसे होगा. वैसे तो 4 ही बच्चे वीडियो देख रहे हैं, बट वो लोग भी है ना. सो एनीवन, प्लीज बी फास्ट. Please do let me know. If this question you know, then I will show you the next question. The next question is कि there is a beaker, and in the beaker there is some oil. There is some oil, okay? And below oil there is water. So oil will have some density. So maybe the specific gravity of oil is 0.7. And what we will do, we will take an object. The object has a specific gravity of 0.8. So the question is, what will be the equilibrium position of the object? So what you will say, the specific gravity of the object is more than specific gravity of oil. So for oil it will sink, but specific gravity of object is less than the water. So for water it will float. This means the object will settle in the middle, A1 and A2. Now what you will say, the object is displacing some oil, so there will be a buoyant force because of oil. The object is displacing some water, so there will be a buoyant force because of displaced water. So what you will say, total buoyant force is equal to buoyant force because of displaced oil plus buoyant force because of displaced water, and this will balance the weight of the body, है ना? So by this you find out the equilibrium position. And in this question I always ask कि भैया, when oil is above the object, then how come you are saying that there is a buoyant force because of oil? Then you prove to me that, sir, actually what is happening, that you just apply hydrostatic law. So here there will be a pressure P1, here there will be a pressure P2. So because this pressure difference, the force because of pressure difference, it mathematically looks like this. समझ रहे हैं आपको? आई होप ये भी चीज याद हो. वेट इज बैलेंस बाय बोथ ब्यूएंट फोर्स ऑफ लिक्विड एंड ऑयल. ठीक है ना? गुड, वेरी गुड. सो अनीश, इसमें ना मैं एक क्वेश्चन पूछता होता हूं कि यार ऑयल तो ऑब्जेक्ट के ऊपर है, तो ऑयल लिक्विड क्या करता है? लिक्विड हमेशा प्रेशर लगाता है, लिक्विड हमेशा पुश करता है. तो लिक्विड क्या करेगा? ऑब्जेक्ट को डाउनवर्ड पुश करेगा. तो आप कैसे कह सकते हो कि ऑयल के कारण ब्यूएंट फोर्स लगेगा ऊपर की तरफ? तो हम हाइड्रोस्टैटिक लॉ से प्रूव करके दिखाते हैं कि सर ब्यूएंट फोर्स का मतलब होता है फोर्स बिकॉज ऑफ प्रेशर डिफरेंस. तो वो जो प्रेशर डिफरेंस का फोर्स है ना, वो मैथमेटिकली ऐसा दिखाई दे रहा है, इसलिए बोल देते हैं टोटल ब्यूएंट फोर्स बोल देते हैं. ठीक है? सो एक क्वेश्चन ये बनता है. फिर कई बारी जैसे अगर ट्रिकी क्वेश्चन देना हो, तो एक ट्रिकी क्वेश्चन तो मैं हमेशा कराता ही हूं. सो मैं बोलता होता हूं कि मान लीजिए देयर इज अ स्टील टम्बलर ए एंड देयर इज अनदर स्टील टम्बलर बी. So in one steel tumbler there is an ice. ठीक है? Now what we will do, we will pour water in both the tumblers so that the final level of water in both the tumblers is same, but in this tumbler the ice will float, है ना? So इस तरीके से आपको final situation दिखाई देगी. So this is water only, this is water only, this is water only. So I always ask, which tumbler will weigh more? So you say कि भैया A and B are going to be equal, and the final reason is the weight of fluid displaced by ice is equal to weight of ice. ऐसा कुछ रीजन देते हैं हम लोग इसको मैथमेटिकली प्रूव करते हैं. और फिर मैं क्वेश्चन पूछ लेता हूं, if the ice melts, which tumbler will have more level of water? So you again tell me that when the ice melts, it will occupy only this much space because it will become water, and the level of water will remain same. So both tumblers will have same level of water. तो इस तरह का एक क्वेश्चन कराते हैं. तो अगर आप लोगों ने ये क्वेश्चन नहीं किया हुआ है तो आप इसको सॉल्व करके देख सकते हैं, और अगर कोई डाउट लगे तो मुझसे पूछ भी सकते हैं. ठीक है ना? सो ये क्वेश्चंस मैं डिस्कस नहीं कर रहा हूं, क्योंकि ये क्वेश्चंस मैंने ऑलमोस्ट हर क्लास में कराई ही है, सभी क्लासेस में कराई है. पर अगर कोई भी स्टूडेंट न्यू है जिसको ये क्वेश्चंस नहीं पता, वो बस मुझसे कांटेक्ट करो या अभी क्लास जब ओवर होती है तो पूछ लो, ठीक है। नाउ चेक वन क्वेश्चन वी शुड डू एंड देन वी विल लीव। सो दिस क्वेश्चन एक्चुअली केम इन इसरो, और मुझे इसकी एग्जैक्ट स्टेटमेंट तो याद नहीं है because this question can have two possibilities. Okay, so we will solve both the possibilities. What it says, there is a bucket like this. So this is the handle of the bucket, and this bucket is hanging on a spring balance. So in the spring balance there will be a reading, and let me consider that the bucket has uniform cross section because it would be easier for us. So these are the joints of the handle, this is the spring balance, and this is the initial level of water in the bucket. Initial level of water in the bucket. Now what they are saying, with help of a rope we will lower down an iron block. So for the iron block, density is given to us 1000 kg per meter cube maybe. Okay, how much? 1000 kg per meter cube. We will lower down the block into water, but we will not allow the block to touch the sides or the bottom of the bucket. ठीक है, हम लोग जो ब्लॉक है उसको अलाउ नहीं करेंगे कि वो साइड्स को या बॉटम को टच करे. And once it is lowered down a little into the water, we will check the new reading in the spring balance. So the question is, if the water does not spill out, question is, if the water does not spill out, question is, if the water does not spill out, then what will be, so मैंने आयरन ब्लॉक की डेंसिटी थोड़ी गलत लिख दी, इट इज 7000 kg per meter cube. Okay, 7000 kg per meter cube. If the water does not spill out, then what will happen to the reading in spring balance? What will happen to the reading in spring balance? Okay, spring balance. Spring balance. What will happen to the reading in spring balance? दीपांक, अनीश बेटा थोड़ा सा ध्यान से, थोड़ा सा मिस्टेक हो गया, हल्का सा मिस्टेक हो गया, थोड़ा सा ध्यान से करना है बेटा, थोड़ा सा मिस्टेक हो गया, थोड़ा सा मिस्टेक हो गया बेटा, थोड़ा सा ध्यान से करो, हल्का सा मिस्टेक हो गया. यस दीपांकर, बहुत बढ़िया, बहुत बढ़िया. सो अनीश बेटा, हैव अ लुक, इट्स वेरी सिंपल. स्प्रिंग बैलेंस, इट इज होल्डिंग द बकेट, है ना. So let me consider the free body diagram of the bucket only. I will consider only the free body diagram of the bucket. Now, once you talk of bucket, obviously the bucket will have its own weight. So let me call it as weight of the bucket. Then the bucket is in contact with water. So water is going to apply pressure force on the bucket, and the same pressure force will act on water also, and this pressure force will balance the weight of water, है ना. This will happen. But how do you calculate this pressure force? I think to calculate the pressure force you will use hydrostatic law, rho g h a. So rho is the density of water, h is the height of water, and a is the area of cross section, है ना. This is how you will find out the pressure force. And the bucket is hanging on the spring balance, so there will be a spring force, and actually the reading means spring force. What is the reading? The reading is always the spring force. Now on the bucket, the weight of the bucket is acting downwards, the pressure force of water is acting downwards, and the spring force is acting upwards. So what will you say? You will say Kx is equal to weight of bucket plus rho g capital H A, right? Now, once you lower down the iron block in water, I think what will happen? The level of water will increase. So if the level of water will increase, H value will increase, the pressure at bottom will increase. Therefore, the pressure force at the base of the bucket will increase. Once the pressure force at the base of bucket will increase, the reading will also increase. So reading is going to increase. Yes or no? Am I correct? Yes or no? Am I correct? Yes or no? Am I correct? And the next modification is, what will happen if the bucket is completely filled initially? दूसरा क्वेश्चन ये बनता है, what will happen if the bucket is completely filled initially? Completely filled initially. जल्दी से बताइए, जल्दी से बताइए. What will happen if the bucket is completely filled initially? अच्छा, वो वाला भी बता दूं? ठीक है, हाँ ये क्वेश्चन भी कराता होता हूं, तो ठीक है बता देते हैं. वो एक्चुअली वो क्वेश्चन उसमें भी दिया हुआ है. सॉरी गाइस, सॉरी. So guys, actually the team is telling me that there is an buffering going on. Is it buffering from my side? Please do let me know. Is it buffering from my side? Actually मेरे यहाँ पे upload speed तो सही आ रहा है. Please do let me know. Okay. Very good Dipankar. Very good. Anish, please have a look beta. Solve the question. थोड़ा सा दिमाग लगाओ, आराम से take your time. Give me an answer and then I will show you one more question and we will leave for today. ठीक है? अच्छा, कल स्टेबिलिटी का क्वेश्चन है, तो स्टेबिलिटी में मैं जनरली तो कॉन्सेप्ट ही बताता होता हूँ, बट मैं अभी जब क्लास स्टार्ट कर रहा था तो मैं सोचा कि कल मैं आप लोगों को ना मेटासेंट्रिक हाइट और पीरियड ऑफ ऑसिलेशन भी बता देता हूँ, ताकि अगर इसरो वगैरह के एग्जाम में फेस करें तो वो भी पता लग जाए, क्योंकि गेट वाला एग्जाम का कॉन्सेप्ट तो बहुत सिंपल है ना. सो हम फटाफट से वो कॉन्सेप्ट रिवाइज कर लेंगे और बात कर लेंगे कि मेटासेंट्रिक हाइट की वैल्यू क्या होती है. उसको डिराइव नहीं करूंगा. मेटासेंट्रिक हाइट की वैल्यू क्या होती है, क्रूज शिप, डिफेंस शिप, इनमें इनको कैसे कंट्रोल करते हैं और उसके क्या क्या वैल्यूज होनी चाहिए, पैसेंजर शिप और डिफेंस शिप के बीच में क्या डिफरेंस होता है, यू प्रोफाइल और बी वी प्रोफाइल, इस तरह की बेसिक चीजें देख लेंगे. ठीक है? नो बफरिंग, नो इट्स फाइन. अच्छा ठीक है. सो गाइस चेक. Anish, beta, it's very easy. The second part is very easy. So in second part, what did I say? I said that bucket is initially completely filled. So once we will lower the iron happen, some water will spill out. But the level of water in the bucket will remain the same. If the level of water in the bucket will remain the same, the pressure at the bottom will remain the same. And if the pressure at bottom will remain the same, the reading will also remain the same. So in this particular case, the reading will not change. Okay? So if the bucket is initially partially filled, then the reading will change. And if the bucket is initially completely filled, then the reading will not change. Okay na? Okay. Now the question that Dipankar is talking about, so मैं क्या करता हूँ, मैं कई बार ऐसा क्वेश्चन देता हूँ, मतलब actually I think this is a common question. Now a lot of people are doing this question and it is there in books also. So what they say, that let us suppose you perform an activity while having a bath. So in a big bucket, in a big tub, you fill water up to this level. Now what you do, you take a mug and you take some stones and put them in the mug, such that the mug is floating. The mug has not drowned, the mug is floating. So this is the level of water A. Now what you do, you take out the stones and drop them in the bucket directly. So what will happen to level of water? will the level of water increase or the level of water decrease? This is the question. Will the level of water will increase or the level of water decrease? सही है दीपांकर, मेरे ख्याल से यही क्वेश्चन है ना? है ना? पहले क्या था? पहले वो जो स्टील ब्लॉक थे वो शिप के अंदर थे, अब उन स्टील ब्लॉक्स को गिरा दिया। तो एक क्वेश्चन बन जाता है कि शिप का क्या होगा? तो शिप तो ऑब्वियसली ऊपर राइज करेगा, मगर पानी का लेवल देखना हो तो पानी के लेवल का क्या होगा? वेरी गुड अनीश, बहुत बढ़िया, वेरी गुड, वेरी नाइस. सो आई थिंक व्हाट यू आर सेइंग इज, sir, initially when we are talking of stones are objects which have a density greater than density of water. That's why in the second case when we drop the stones in water they got sunken. ठीक है, जो भी इंग्लिश है, सिंक हो गए. But initially when they are inside the mug they are in equilibrium. So an object can only be in equilibrium when the weight of the object is equal to weight of fluid displaced. It is equal to the buoyant force. So right now the buoyant force which is acting on the object, it is balancing the weight of the stones. So what you will say? You will say the buoyant force is equal to weight of the stones. So density of stones into volume of stones into acceleration due to gravity. Buoyant force is density of water, volume of displaced water into acceleration due to gravity, है ना? Now obviously you will say कि भैया G and G will cancel out. Rho S is greater than rho W, like 2 times or 3 times depending upon igneous, metamorphic or sedimentary. So there are type of rocks na, and since density of stones is more than density of water, so volume of displaced water will be more than volume of stones. Now once you drop the stone inside water, the volume of stones and volume of displaced water is equal only. So initially when the stones were in tub, they were displacing more water. But when the stones are dropped in tub, they will displace less water. So final level of water will be this. So level of water will decrease. है ना? ये भी एक क्वेश्चन बनता है. फिर कई बार अंडरस्टैंडिंग के लिए मैं ये क्वेश्चन पूछ लेता होता हूँ, एक वो सबमरीन वाली डिस्कशन कर लेता हूँ कि सबमरीन तो स्टील की बनी होती है, देन हाउ कम इट कैन रिमेन एट वन प्लेस? सो यू टेल मी दैट सर सबमरीन इज हॉलो फ्रॉम इनसाइड, सो देयर इज लॉट ऑफ एयर इन द सबमरीन, सो इट इज नॉट अबाउट द डेंसिटी ऑफ वन component of submarine, but it is the average density of object. So even if ship is made of steel and concrete, but the average density of ship is less than density of water. Average density of submarine is equal to density of water. That's why it will stay at a place. And then you guys tell me the concept of ballast tank. So when we want the submarine to go down, we will open the ballast tank. So high pressure water from outside will come inside. So average density of the submarine will increase. So initially the average density of submarine was equal to density of water. So it was at one place, neutral. But when water comes inside, the average density increases. So it starts sinking. Similarly, if you want to go up, you pump the water outside. So average density will decrease. It will become less than density of water and it will start going up. तो हम इस तरह की डिस्कशन करते होते हैं, है ना? और कभी कभी मैं ये क्वेश्चन पूछ लेता होता हूँ कि मैं ये सिचुएशन पूछ लेता हूं, कैन द सेंटर ऑफ ग्रेविटी ऑफ एन ऑब्जेक्ट बी लोअर देन सेंटर ऑफ ब्यूएंसी ऑफ ऑब्जेक्ट? कैन द सेंटर ऑफ ग्रेविटी कोइंसाइड विद सेंटर ऑफ ब्यूएंसी? कैन द सेंटर ऑफ ग्रेविटी बी अबव द सेंटर ऑफ ब्यूएंसी? सो ये क्वेश्चंस हम डिस्कस करते होते हैं. And then there is one more question. So many times we discuss, sir, when I am holding the object in air, air is also applying pressure forces. So is there no pressure? Is there no buoyant force over here? Yes, there is a buoyant force over here, but the density of air is very less. So weight of displaced fluid is very less. So buoyant force is also very less. है ना? So ये हम एक point रखते होते हैं. And then there is a question that if you weigh the object in air, the weight of the object is 200 Newton. And when you weigh the object inside water, the weight of the object is 100 Newton. So what is the density of object? इस तरह का एक क्वेश्चन आता है ना? So मेरे ख्याल से यही पॉसिबल क्वेश्चंस हम डिस्कस करते हैं और इसी तरह के क्वेश्चंस जो हैं पूछे गए हैं. So एक काम करो, क्विकली गो थ्रू करो अगर कोई भी ऐसा क्वेश्चन लगे जो आप लोगों को नहीं आता है, देन आई विल एक्सप्लेन इट. मैंने कोई क्वेश्चन सॉल्व नहीं किया है एक्सेप्ट फॉर दिस वन ऑन द फाल्कर क्वील. बट अगर कोई भी क्वेश्चन लगे नहीं आता है तो मुझसे पूछ लो एंड आई विल टेल यू द कॉन्सेप्ट. ठीक है. सो ऑल ऑफ यू प्लीज गो थ्रू इट, प्लीज गो थ्रू इट. कई बार मैं डेराइव भी करता हूँ बुओयेंसी को. सो आई हैव 3-4 मेथड्स विद द हेल्प ऑफ विच वी कैन डेराइव द buoyant force. So either you can use the concept of hydrostatic forces or you can apply some logic also. तो ऐसे 3-4 मेथड से buoyant force derive किया जा सकता है. तो कुछ भी डाउट हो पूछ सकते हैं, कुछ भी डाउट हो पूछ सकते हैं. तो these are the probable questions. ये वाला सबसे पहले तो the fraction of object inside water or fraction of object outside water. Then this kind of free body diagram kind of question. हाँ ठीक है दीपांकर, कल मिलते हैं. कल सेम टाइम पर. एक्चुअली 9:30 का टाइम मुझे पता नहीं, शायद गलती से हो गया. वैसे 9 बजे का टाइम दिया हुआ था. तो अगर कल 9:30 हुआ तो आपको पता लग जाएगा. ठीक है. सो टुमारो द क्लास विल बी ऑन स्टेबिलिटी एंड लेट मी चेक. स्टेबिलिटी के बाद जो नेक्स्ट क्लास होगा दैट विल बी ऑन लिक्विड्स इन रिलेटिव इक्विलिब्रियम. देन द नेक्स्ट क्लास विल बी ऑन फ्लूइड काइनेमेटिक्स. एंड इन दिस वीक someday in the afternoon I will release 2 videos for fluid kinematics and fluid dynamics revision videos, 1 hour 1 hour. ठीक है. और तेरा जो डायमेंशनल एनालिसिस और पंप है उसका प्रॉब्लम सॉल्व करेंगे इस हफ्ते. ठीक है. ये मेरा ऑब्जेक्टिव है. सो ठीक है. सो दिस इज द क्वेश्चन फ्रैक्शन. Then this particular question, if an object goes into a liquid of different density, what will happen to this fraction? Whether the object will sink a little or the object will come out a little. Or this type of a question, if you drop an object in 2 layers of fluid, what will be the final equilibrium position of the object? Or this kind of tricky question कि भैया कौन सा ऑब्जेक्ट का वेट ज्यादा है. ये भी एक ट्रिकी क्वेश्चन था फ्रॉम इसरो. एंड देन वी टॉक्ड ऑफ दिस वन. सो दिस इज अ जनरल क्वेश्चन इन ऑल द बुक्स, है ना. और ये वाला कि अगर आप उसको वैसे होल्ड करते हैं, इट इज 200 न्यूटन. व्हेन यू होल्ड द ऑब्जेक्ट इन वाटर इट इज 100 न्यूटन. व्हाट विल बी द डेंसिटी ऑफ ऑब्जेक्ट? एंड आई थिंक दिस इज वेरी इजी. सो what will be the reading in weighing machine? The reading in weighing machine will be actual weight of the object minus the buoyant force. This is the reading in weighing machine. So when you are holding the object in air, there will be a buoyant force because of air. So you will say reading corresponding to the air. When you are holding an object in water, there will be buoyant force because of water. So you will say reading because of water. You put here 200 Newton, you put here 100 Newton, you will get your answers, right? ठीक है. तो ठीक है, फिर आज के लिए बस करते हैं एंड सी यू इन द नेक्स्ट सेशन. सी यू टुमारो. थैंक यू, बाय बाय. एंड प्लीज जो भी लोग बाद में वीडियो देखेंगे, अगर कोई डाउट लगे तो आप लोग मुझसे पूछ लेना. ठीक है. तो राइट नाउ आई विल शेयर द वीडियो इन द ग्रुप. तो मेरे जो करंट स्टूडेंट्स हैं बैच वाले भी, कभी भी डाउट हो तो पूछ लेना उसी टाइम. ठीक है. टेंशन नहीं लेने का. चलो बाय बाय. देखो याद रखो, ये जो क्लासेस हो रही हैं रोज रात को, इनका ऑब्जेक्टिव यही है कि एक आध क्वेश्चन कर लें 40-50 मिनट लगा के, और अगर थोड़ा बहुत टॉपिक रिवाइज हो रहा है तो टॉपिक रिवाइज कर लें. अभी मैं हल्का हल्का ही चल रहा हूँ. हल्का हल्का इसलिए चल रहा हूँ क्योंकि ये वाला जैसे आज का टॉपिक था, इसमें सिंपल क्वेश्चन आता है. बट काइनेमेटिक्स में जाएंगे तो थोड़ा सा ट्रिकी हो जाएगा काम. डायनेमिक्स में जाएंगे थोड़ा सा ट्रिकी हो जाएगा काम. ठीक है. थोड़ा लेंदी क्वेश्चन करेंगे. एंड हैप्पी न्यू ईयर टू ऑल ऑफ यू. टेक अ रेजोल्यूशन, स्टडी हार्ड, वर्क हार्ड. स्मार्टनेस विल कम बाय इटसेल्फ. डेफिनेटली बहुत सारा स्मार्टनेस आएगा. ठीक है. एंड हैप्पी न्यू ईयर टू यू एंड योर फैमिली. ठीक है. थैंक यू अनीश. थैंक यू. बाय बाय. सी यू इन द नेक्स्ट ईयर. थैंक यू. बाय बाय.